right, so thanks for coming, Ronen. From Run AI, we really appreciate you kind of joining us in our little car ride. Hopefully you haven't been to Belle Isle, so you can see that. It's like one of the famous points in Detroit, and really pretty, I think.
Cool.
But yeah, thanks for coming.
Yeah, thanks for having me.
Yeah. So first up, okay, so what is it that Run AI does exactly?
Okay. So Run AI is an AI computing platform.
Uh-huh.
We're working with large enterprises, the largest in like banks, automotive, healthcare, a lot of research institutes. So I know research institutes are close to your heart.
Yeah.
So we're working with a lot of advanced research institutes, and we essentially help them centralize their AI infrastructure.
Gotcha.
And allow them to make better use of GPUs and their computing resources, and essentially provide easy and simple access to computing power to their researchers, data scientists, AI engineers, and so on.
Gotcha. Okay. And so how do you present it to the end user? Is it part of the Run AI system to actually for an end user to participate in it, or is it more on the kind of the ops side?
You mean in terms of the
platform? Do I roll up there to get a Jupyter notebook?
Yeah. Okay. So we bring a lot of technology in terms of building ourselves on top of Kubernetes, and there's a lot of things going on under the hood, right? And I know researchers and data scientists, they don't want to know much about Kubernetes, right? Yeah. They just want to run their jobs, experiment with data and with models. So for sure we know that, and we're bringing tools for them to simply run their jobs, run their workloads, experiment, open Jupyter notebooks. So we do all of that as well. But what's unique with us that we're truly open, we like to call, we can integrate with any tool, MLOps tool or data science tool that run on top of Kubernetes. You can get simple, very native integration to our platform as well, because we're based on Kubernetes and we built it like that. So we have our own tools, and then we can integrate with any other tool.
I gotcha. Okay, that makes sense. So you were saying before that you're kind of doing a lot more with GPUs, you mean kind of surfacing it up to end users, or how is it, what is it that you're bringing to the table kind of that helps, making GPUs accessible?
Yeah, so GPUs today, there's a big problem, I think, and we encounter it time after time. There's a big problem with efficiently utilizing GPUs. So GPU utilization is a big problem, and we see it in a lot of organizations. It's an expensive resource.
Right.
I think on Amazon, when you take just one GPU, it costs $30 per hour. So the newest GPU.
Yeah.
So it's an expensive resource.
Right.
And researchers, data scientists, they need a lot of it.
Right.
And it's really important for their work. So getting access to that to those computing resources and utilizing in the right way, in an efficient way, that's really difficult. So it's utilization, and the other thing is sharing the GPUs between your team members, between your organizations, between multiple teams. That's difficult to do that dynamically.
Yeah, because GPUs are definitely not designed for that.
Yeah,
right?
So they're definitely not designed to that. Yeah. And I think if you look at on GPUs and you compare them to CPUs, so for CPUs, for 30 years, a lot of software was built to just abstract the CPU usage, right?
Right.
You don't, when you run your workload on CPU, you don't even care about on which exact core CPU core the workload runs. But it's not like that with GPUs. Yeah.
Right. Well, a bunch of my students have been having problems lately because they're running M1 Max, and a lot of a CS class, right? There's virtualization and stuff, and they're totally can't do anything because they it's an ARM chip and they can't virtualize anything. So it's funny because it didn't even cross my mind, when people started showing up with M1s, that this was going to be a problem,
Yeah,
but exactly, right?
Same thing with our engineers. Yeah. Something broke in the abstraction layer, and now everyone notices it. And with GPUs, that abstraction layer, it's not exist. It sort of not exist.
So, because most people want to write raw to the GPU in its traditional model, right? If you're writing a video game, right, you don't want any abstraction layers between you and the GPU.
Yeah. So people work like that. They get access to one GPU, to two GPUs. They hug those GPUs.
Right.
And they often utilize them, often not. And so you're getting a problem with the utilization of those expensive resources. And many times we see idle GPUs while other teams, other other researchers are waiting to get access to GPUs.
Right, right.
So we're doing a lot of work in that sense, and providing tools and efficient software and abstraction layers to help customers better utilize their GPUs.
Gotcha. Yeah,
And
that makes a lot of sense. And I think you kind of mentioned it a little bit, but I think that separation problem is also really, really important, right? Because, you know, like I'm not actually a researcher myself. I'm more on the clinical side. So, but, you know, I've done a lot of software, and it's, you know, you want to make sure that you're not tainting, you know, the work of somebody else, especially on a platform that is not really designed to be shared. So do you feel like you're doing a good job of that? Is that one of those things that you really feel like Ronen AI is bringing to the table?
Yeah, I think today researchers they deal a lot with the infrastructure, and a lot relates to that on how they shift their environments and software from one place to another.
Yeah.
So that's really difficult today.
Yeah.
Just shifting your environment from one GPU to another GPU, that could take like 2 weeks for you as a researcher sometimes, right? So with containers and our platform is built on top of Kubernetes, so you can simplify a lot of that, right? And if you can create, and we're building a more dynamic platform to help them shift their environment, shift their workloads between GPUs, and use those resources in a smart way.
Right. Yeah, that's pretty cool. So of course, you know, I am biased towards open source because I, you know, used to work for Red Hat, and now I work at a university. But you were saying that you've been pretty heavily contributing to 2 open source projects.
We're creating we created recently 2 open source projects, and one for monitoring GPUs, and the other for to help the community and people share GPUs and provision GPUs in an easier way.
Oh, nice.
And so because, you know, we're based on Kubernetes. And we're doing I love Kubernetes. I think it's an amazing framework. It's an amazing piece of technology, and it brings so many good things to the world, right?
Right.
So we're using Kubernetes, and we're based on Kubernetes. So we enjoyed what the open source created.
Right.
And I feel really, I believe in karma, and I believe that we got a lot, and we need to give back, right? So I'm looking for ways to help back the community and just solve problems for the community.
Yep.
So one problem that we identify is a problem with monitoring the utilization. Many times people don't even know what the utilization
how bad the utilization really is.
How bad is the utilization, and what even is the utilization? You know, IT teams, they only get requests to buy more GPUs, to increase the limits in the cloud, to have more GPUs, but they don't even know what's the usage. So we created this tool, we call it RNTOP, and I think it really simplifies non-Kubernetes environments and to monitor non-Kubernetes environments. The other tool is called GENV. GENV, we took a lot of inspiration. Our engineers, it's not me. I don't do much, right? We have amazing engineers, and they took inspiration from PyEnv and Conda, Python libraries for data scientists. So they created GENV.
I get it.
And it helps teams of data scientists to share GPUs in an easier way, simpler way, provision GPUs in a simple way. So we just released it like a month and a half ago, I think. It already has like hundreds of downloads.
Yeah,
actually, because we integrated it into PyCharm and into VS Code. And we're getting a lot of downloads from there. So I don't know, that's fun.
Pretty cool.
Fun to see.
Yeah. Have you talked at all to an organization called Massachusetts Open Cloud? By any chance?
No.
So there's an organization that is, it's sponsored by some industry, you know, companies like, so Red Hat is obviously a sponsor. That's part of why I know about it. But BU is also a sponsor. But so is Harvard, and you know, and basically what they're trying to do is like, can they build an open cloud? But really, what they want to do is they want to give access to researchers to like the underneath parts of a cloud, which you can't really get from like Amazon, you know, for that much. But in order to give real world data about what's going on the under cloud kind of, they also need to give, they want to have real workloads. So they have researchers kind of sitting on top doing data science research, but then they have other research looking underneath to seeing what it does to it. But that might be a really good kind of place for you to get involved with like the GM, right? Is like that's the kind of thing they're experimenting with. Is like how can they shift workloads, say, between clouds, for example, or how do you make one of the big things they want to do is like Harvard, let's say, has, I don't know, 20 machines, but at any given point, right, at 2 a.m. on Thursdays, they don't actually have anything running. And so they want to loan that to another organization, but they want enough control that they can bring it back, right? So that's one of the problems they're trying to like solve. But it's kind of the same utilization thing, except it's cross-org.
Oh.
Yeah, because Harvard wants to give the resources to BU, and then, some later day when BU's got free resources, they give resources back to Harvard. Because it's a bunch of universities, so they don't have a vested interest in kind of protecting their little silo. And then Red Hat, gets involved because they want to see how their software performs, right, at that kind of scale. So it just might be a really good opportunity for a relationship.
Sure, we would love to do that. That's we're doing a lot of work in terms of sharing resources between teams, between organizations.
Right, and I think the Mass Open Cloud one, right, is an even harder problem. So if you can solve that one, right, you can definitely back into the within one organization problem.
Multi-tenancy, it's always more difficult.
Yeah, it's especially if you don't design for it from the get-go. That's one of the really difficult things to retrofit onto software, at least in my experience. So that's really cool. I like it. Here's Belle Isle. It's not as pretty today as it was yesterday.
Wow. Still pretty.
But it's still very pretty. And so this is all U.S. territory, but we're like an inch away from the line in the water between us and Canada.
Oh man, there are houses on the lake. It's a lake or it's
a river?
It's a river, right? Very nice. Oh, that's okay. Got it.
Which is one of the big ones.
That's beautiful.
Yeah,
that's beautiful.
But it's especially for an American. Do you live in the U.S. or?
No, I lived in the U.S. Now I'm living in Israel. So I did my postdoc here in the States.
Oh yeah.
And so I've spent here several years in New Jersey, in Hoboken.
Oh, okay. All right. Not everyone's favorite choice of parts of the U.S., but I understand. So you've probably heard the phrase our neighbors to the north of Canada.
Yeah.
But Canada is actually south of us here in Detroit.
Oh yeah?
Yeah, because Michigan kind of curls around and Canada is kind of underneath it. So it's really weird because you go over the river and that's south to get to Canada. It's very confusing for most Americans, I think. Are you in Tel Aviv? Did somebody tell me you were in Tel Aviv?
Yeah, we're based in Tel Aviv.
Okay.
We're based in Tel Aviv. We have offices in the States, but Tel Aviv is amazing. Have you been in Tel Aviv?
No, so what I was going to say is Red Hat has a big office there, and that was one of the places that I was like, I need to find an excuse to go visit that office because I really want to go to Tel Aviv, but I've never been.
Of course, KVM is an amazing.
Right.
KVM, right there. Red Hat bought the startup that invented.
Yeah, I can't remember what they were called.
It's their founder is one of our investors.
Really?
Benny Schneider. Yeah, he's amazing.
Oh, that's cool.
He's the first founder. He's the first investor in our company.
Oh, nice.
We love him. He did a lot of things in virtualization, and we love virtualization and abstraction layers. So
it seemed natural.
It seemed really natural. So Red Hat have big offices in Tel Aviv, and all the big players, right? Google, Amazon, all of them are having thousands of employees in Israel. But Israel is became an amazing hub for startups.
And I think of it as security and crypto, especially.
Security, crypto, and AI.
Yeah, that's interesting. I mean, now that you say it, I'm like, oh yeah, okay, I can see that.
But I tell you why, because a lot of people are coming out of the army. So in the intelligence units in the army, everyone go in Israel to the army when they are 18 years old, right?
Yeah.
So
it's actually something I think they should do here, but a year of service or whatever.
It does good for Israelis because many people are going to the intelligence units and they deal with technology. They're doing a lot of things around cyber and security, right?
Yeah, that makes sense.
And they're doing a lot of things with AI. Then you have a lot of AI in the defense organization. So they go out of the army, and many of them are starting companies. My co-founder, for example, he served for many years in the army. He went out and we started together Run AI.
Oh, gotcha.
So so there is.
Oh, I did the same thing the other day. Yeah, there's like a bunch of roads that are closed, and so I was with Liz Rice in the car, and she got a nice little tour of this parking lot as well. So here we go. But yeah, so I've actually always wanted to go there, but just have never kind of had a chance.
You should.
But one of these days we'll see what happens. There were like 3 offices at Red Hat, that I wanted to like try to get before I ever left Red Hat, and that were left. I had a whole bunch of them that I wanted to go to.
Tel Aviv is amazing. You should come in the summer though.
Yeah.
Summer is amazing in Tel Aviv.
Even not too hot.
Oh July, August is a little bit too hot, but summertime.
Like late spring would probably be best for me. Yeah.
Summertime in Tel Aviv is like most of the year, right?
Yeah, right. Well, that's true. Right.
2 or 3 months of winter, right?
Yeah. It's kind of like I was going to India a bunch, and there was a conference that in Pune that somebody wanted me to come and speak at, and I was like, "Your conference is in August in Pune." I was like, not the time I really want to visit Pune. I'd much rather go like in, January.
For sure.
But
sure.
Yeah.
How is Boston right now? So
it's very similar here, actually. It's got as much choppiness about because I don't know how many days you've been here, but like it's been gorgeous all week, and then today is kind of cool and rainy. But Boston's been the same. So it's like we had a bit of a cold snap, and then it got really nice again, and it'll do that a bunch for the next month or 2, and we'll see what happens. But I like the cold, so I have a hard time with warm temperatures.
Got it. Got it. Makes sense. Okay.
But that's part of why I live in the Northeast. So all of your kind of infrastructure runs on Kubernetes, which I totally get then why you want to be kind of engaged with the community at KubeCon. But do you also have kind of customers you want to see here, or do you have like developers, or are there people that are kind of in your target market that you feel like are at KubeCon as well? Yeah,
for sure.
Yeah,
no doubt. So our customers are many times the IT side. IT, and when I'm saying IT, is the people who are building the platforms,
ops,
machine learning platforms, or machine learning infrastructure, right? So those people are usually engineers, and they know a lot about Kubernetes, and they are building the platform internally, and so they are engineers. They know a lot about Kubernetes,
right.
And so, and they are here as well in KubeCon.
Right.
KubeCon is exciting. That's
well, it's fun too, right?
Yeah.
But that's not usually enough justification for spending the money.
And that's one thing. So customers for sure. Customers for sure. But also we're doing a lot with Kubernetes.
Right.
We're not just building on top of Kubernetes, but our engineers are doing a lot of things internally in Kubernetes. So we've built our own scheduler. Kubernetes.
Right. So why did you build your own scheduler? What did you feel like you were trying to do differently?
Yeah, so the problem of utilizing GPUs relate much to scheduling problems. So scheduling on GPUs, that could be sometimes difficult.
Right.
And for AI, when you're running AI workloads which are really compute intensive, and they are using expensive resources like GPUs. What we saw that there are scheduling capabilities that are known from the HPC world. I don't know if you know high performance computing. And so scheduling scheduling concepts from there, from HPC, and scheduling concepts from Yarn, from Hadoop.
Okay.
So that's it. So when we built our platform, we saw that many scheduling capabilities from there, like queuing, and preemption, and fairness, sharing allocating the resources in a fair way, quota management, advanced quota management, and gang scheduling. I think that those things were missing in Kubernetes, and we saw that they are really needed.
Right.
So to enable like efficient platforms. for machine learning. So those scheduling capabilities are really important for AI.
Yep.
So we built them, and we built a scheduler that plugs into Kubernetes environments, and bring those advanced like HPC capabilities into the AI world.
Right. Schedulers are really interesting. I mean, one of the things it's funny because you talk about AI, right? Is that I don't understand why we haven't seen more AI kind of to create schedulers, or schedulers that are enabled by their own machine learning. It's like I was toying around with an idea for a while of there's a whole organization at Red Hat. There's whole organizations elsewhere too that are putting out perfectly optimized tunings for databases on RHEL, for example. But it's well, how expensive would it be to actually just run a little machine learning model on the machine itself that's kind of watching the kernel and saying, hey, we're getting spikes like this. Why don't we twiddle this knob and try it for a while, right? And then go on to the next one. Oh, that didn't work very well, so let's just turn it back. I wonder why, I feel like we could be using the machine learning techniques we know to kind of modify schedulers based on what's literally happening at the moment. Which I always think is kind of interesting. But you have to have the capability, right?
Scheduling is interesting. I think if you look at the history of the schedulers, the HPC schedulers in Hadoop and Kubernetes, Mesosphere, right? They came also with their own schedulers. So scheduler is the heart of the system of orchestrators, right? Platform. So it's an important aspect of a system working. So scheduling can be done in different layers. Mm-hmm. So you're speaking about the low-level layer. Mm-hmm. And for sure, I think I totally agree with you. You can do things with machine learning just to optimize certain specific workloads with specific patterns.
Right.
So you can use AI to schedule. It's somewhat,
But why do I have to tell the computer there's a database running on it? It can figure it out for itself and then tune itself. Is kind of what I've been wondering. And so with but Kubernetes scheduler, right, distributed system schedulers are super interesting as well because you have all these other kind of variables at hand, right? Because you not only have the obvious stuff like load, but you also have things like our resource, the amount of resource we have changes. Right, as you add machines to the cluster or remove them from cluster and stuff like that, you have all these other things going on in a distributed system environment, that's way beyond just, kind of a simple, single kernel environment. So I think schedulers are.
Do you think it will go to a place where right now users are deciding on the amount of resources that are going to be allocated to each workload, right?
So which is totally a mistake.
Totally a mistake.
Because it's and this is where kind of we're already kind of doing it or recognizing it, right? That's what auto scaling is. Is okay, so the humans can't actually predict in advance what the scaling needs to look like. So we've introduced these auto scalers. But can't you just do that with all things, I wouldn't be surprised if that's the way it's going,
Yeah, for sure. We, in terms of GPUs, we're providing basic scheduling capabilities.
Mm-hmm. Well, because the feature set in order to schedule this stuff wasn't really there either, right? That's why you had to go and look for, ways to monitor the actual utilization because then it can inform the scheduler whether or not to put something there.
Yeah, right? So right now in Kubernetes, you can allocate just whole GPUs, one GPU or two GPUs, right? You can't really allocate fractions of GPUs, not like with CPU or with memory, right?
Yeah.
In terms of the request and versus limit, when you request resources, you have the request value, the limit value. With GPUs, they are always equal. Mm-hmm. Versus in CPUs and memory, where request and limit can be different, and that can provide value in terms of over provisioning.
Well, and can you do that on a GPU? Is it?
You cannot. With
AI,
you can do it.
Okay, well, that's what I mean. But but I mean, on the physical hardware, can you use a fraction of a GPU? I guess that seems odd to me. I feel it's kind of on or off.
Listen, you can do things like time sharing.
Right. Yeah, that's true. Definitely.
And NVIDIA also bringing more advanced capabilities into hardware fractioning.
Yeah.
Just splitting up the GPU into hardware pieces. That's different. But we're doing more like time sharing on the GPU itself, and then you can allocate fractions of a GPU.
Right. Okay. All right. Yeah, that makes sense.
So that makes sense a lot for when you have when you're deploying your models inference right on GPUs. Then not always you need a full-blown GPU.
Right. Oh, for sure. Yeah. I would say the utilization of most GPUs is probably not high. Even under an AI scenario.
What we see that the average utilization is much below 20%.
Yeah, that's what
20% is high. Usually we see even less than 10%. So that's crazy because organizations are investing tens of millions of dollars, if not hundreds of millions of dollars on their GPU infrastructure, and the utilization at the end is like 10%. That's
right. That's not a good ratio.
That's worth a lot of money.
Right. Well, I mean, it's funny, right? Because it's kind of throwback to before virtual machines. It's like the utilization you get on straight hardware was on CPUs was terrible, like 20%. And then even when we started doing virtual machines, getting utilization, you'd start to get utilizations in like 60, 70%. But I mean, that's why containers are so awesome, because you can like get ridiculous density and you can over provision such that if there is even some utilization room, you can shove something else in there really easily, which I think is, really interesting.
That totally. I totally agree. That's containers are amazing.
Right. Well, it's funny because it's like even in my advanced classes, because I teach very, very like first semester freshman year students, and I also teach like ones who are like seniors and graduate students. And so I have both ends of the spectrum. But even the seniors and graduate students, like trying to explain to them, like, because they didn't live through it, right? So, but trying to get, show them it's like, okay, so I have straight hardware, right? And then I have virtual machines, and then I have containers, because what we want is we want every iota of computing power to get used, right? To maximize the amount of, if we spend a certain amount of money, we want to use as much of that as we can. And we don't do that in most other scenarios. We do get very good utilization. Right,
and I think like now a big story that is happening in the world right now is around like even increasing those abstraction layers in terms of like the layers, the level of the layers of abstraction with hybrid cloud and multi-cloud story. That's an amazing story.
Right.
And we're hearing it a lot from customers who are, they are building the platforms, the services, and they strategize around multi-cloud or hybrid cloud solutions. And so we're hearing it a lot from customers. That's big. That's big, and it's a lot enabled by Kubernetes.
Right.
I believe that all companies, all startups, and now on will build their services or their platforms as a hybrid cloud or multi-cloud solution. If now I'm building a new service, I will build it as a multi-cloud service on top of Kubernetes. There's no reason not to do that. Right?
Yeah.
So because the value is so big.
Right.
If my service, my platform for internal use or external use can run on any cloud, on premises.
Right.
And the same way, with the same stack, through the same platform, that has huge benefit to customers, right? To users.
Yeah, exactly.
In terms of abstracting that cloud infrastructure out of it, right?
Right, and it makes you a lot more flexible. But I bet it also brings the utilization problem back.
And it's
right. It's like as good. You have your perfect data center if it even exists, right? And you've gotten that really high utilization with containers and Kubernetes or whatever. And then you're like, oh, but we want to do hybrid cloud. And so now you have, like I said, you just brought that utilization problem back, and you need to optimize for it all over again.
Yeah.
So it's kind of
it's a game of always abstracting and then improving and the efficiency.
And then you kind of take the next step or whatever. Yeah, that's totally cool. So are you giving any talks or anything at KubeCon?
My guys had, sorry, not my guys, my engineers. They had a presentation yesterday in the AI Day.
Oh, okay, cool.
Yeah, so
that's right. You did one of the pre-conference events, right?
Yeah, the AI Day.
Right.
And we had a presentation there on GPU utilization.
Yeah.
And it was amazing, I think. The entire day was amazing. I really loved it.
Yeah.
And so it was really really fun.
Yeah, it's weird. Like, I've been doing this stuff a long time, right? And it's like, and so, but I get really fascinated by, kind of talks about things where it's like breaking all the things, and AI has actually been a long time love of mine. When I went to college, my grand plan was I was going to do philosophy undergrad and then go to grad school and do AI by doing CS. Because in those days, because I'm old, people thought of AI as a hybrid of philosophy and computer science. Now they think of it as more like psychology and computer science.
Okay.
But so that was my original plan. And then I took a CS class in my sophomore year, like second semester sophomore year. It was the intro to CS. I was like, oh, I'll just try it out, and and it was like a cakewalk of a class. I was like, this is so easy, and I was really having a hard time in philosophy because I don't learn other spoken languages very well, and I had to do Latin, and was not doing very well at that. And I was like, I'm just gonna switch, and so I switched to CS, and that's where it went.
Listen, I'm an electrical engineer.
Uh-huh.
That's my background, and I started a software company. Right. So that was fun. I learned so much on how to build a software company and how to build
good software too.
Good software, good software products, right?
Right.
And when we started, me and my partner, we both of us electrical engineers.
Yeah.
So both of us knew that we want to build a software company.
Yeah.
Because that's the way, it's software companies. That's the way to go, right?
Right.
And the benefits are amazing. You can really change the world with software.
Right.
And so we knew that. We also knew that we want to be in AI.
Mm-hmm.
We saw the amazing things that are going on in AI. And then it's really big revolution. It's going to change the world.
Oh yeah, it already is. I mean,
it already is. Like for sure, we're driving in a car. You're driving.
Yeah.
Like
but even just navigating maps, right? Auto navigation. I mean, it's in there all over the place. You don't even realize it. Which is the promise in my mind of good computing, good software is you shouldn't even see it, right? It should just work.
For sure, and it's changing the world as you see already now with autonomous cars and everything, and much more than that. And we wanted to be part of that space,
revolution,
of that revolution, and help, right?
Right. Yeah. I think we'll shout out to Ford, right? I mean, this car, right? It's it'll do auto parking and auto driving to some level and stuff. And I have both the curmudgeon-y aspect too. It's I actually like driving. I like kind of the control and and I missed having a stick shift. But at the same time, one of the things that really blew my mind about autonomous cars was I saw this GIF somebody had put together to try to explain autonomous driving. And one of the things that just kind of blew my mind was that when you have computers doing the driving and there's a stoplight, if you start going, all the cars start moving at once.
Oh,
because they're computer. Because they can all move at once because they're all right. So it was super interesting, and I never really thought about that because as humans there's a delay in our response time. Right?
Crazy.
Yeah, right.
That's so fun to see, right?
Yeah.
They are all synced with the light.
Right. So thank you so much for your time. We definitely are out of time, but really it was a pleasure having you.
Yeah, that was fun. Thank you so much.
Yeah, hopefully you enjoyed a nice little tour.
I did. That was amazing.
All right, thanks so much.